My name is Avik. I work at LinkedIn on the mobile team. One thing we've been doing on the mobile team is doing hand-drawn presentations, and I really like that. It makes the presentation a lot more personal, and I think that's really appropriate for this because this is a very personal story. It's a story about how you can start with some very reasonable small decisions, and as you make more and more of them, you end up in a state where one component is fundamentally broken. So I'm sure a lot of you can relate to that. And this is the story of how we took that thing that was broken and found a solution without tearing everything down and rebuilding it from scratch. So the story starts a year ago, but let's go back a little bit further. In 2011, our phone app looked kind of like this. It was very cluttered. It had a lot of icons when you first started up. And in 2011, we released an update that simplified it quite a bit. So we put your network updates right in the front. We made the navigation much simpler. And in doing so, we also changed the technologies that we used. This is the first time that we used Node.js. And the architecture looks kind of like this. You have the mobile client. It talks via HTTP to the Node.js server, which in turn talks to one or more backend services. The Node.js server retrieves JSON data from the backends, maybe aggregates multiple pieces of data, and sends it back to the client to render one page. This is not a very unique architecture. A lot of you have seen this. But one thing to note is that this backend that I'm talking about is basically the public API that is exposed by LinkedIn. At least that's what it was at the time. And we were acting a lot like a startup. We were kind of semi-independent. We were acting like a third party, and that is reflected in how we were set up. See, you could be using the app anywhere, but we were not even in the same data centers as the rest of LinkedIn, and we were deployed to some machines on a different data center altogether. And we would just hit the public API that LinkedIn offered, api.linkedin.com, and it worked. But of course, we needed to get into the same data center as the rest of LinkedIn. And that's already a non-trivial task because our deployment architecture would be different. We had to set things up. So we couldn't change everything. And in particular, we had this issue where if we wanted to talk to the same APIs internally, we wouldn't be doing the same OAuth song and dance that we're doing now. And so for a little while, our architecture looked like this. We were in the same data center as the rest of LinkedIn, but we were actually going outside through a Squid proxy because those data centers don't have external internet access, and then coming back into the data center to hit the backend. That's been fixed. We're no longer like that. But it was like that for a while, and that meant longer times to serve each request because we had to do a lot of, we had to go out of the data center and come back. But that's one aspect of it. The other aspect is when you're developing. So first of all, once we were inside the LinkedIn data center, we could start accessing other APIs that were internal only. That was one big benefit to moving inside. But let's look at just the Node.js server and the backends it talks to, because I'm primarily a server engineer. And if you're running this on your local development machine and talking to some backends, then maybe you're doing it over Wi-Fi or something like that. And so this connection is not the best. It's true that inside the data center it's a little better, but when you're developing on your own machine, it's not the best. And the other thing we want to do in development is test it. So obviously there's unit tests. That's a given. And the other type of test we want is something that tests the system as a whole. So what we're going to do is we're going to pretend to be a mobile client. And we'll make some HTTP requests and get back some data and see if that data is OK. So that's what we want to do. But there's some problems with it. As I said, the connection to the backend services is not the most reliable coming from your development box. And of course, before we fixed the problem of going and accessing the public API, we were still accessing the public API even from our local machines, so this was pretty unreliable. Another problem is that it was fundamentally slow. So what does slow mean? Well, one request that the Node.js server would make, maybe it takes 100 milliseconds, 200, 300 milliseconds if it's something big. But that's a lot of time for one test. If you have 100, 150, or more integration tests, then this is going to add up. And OK, it may not be too bad, but you still don't want anything even on the order of minutes. Why? Because you want developers to run these again and again and again. Let me put that in perspective. Our unit tests, we could have 2, 3, 4,000 of them, and they'll still run in 2 seconds. And we can't do that with the integration tests. And for whatever reason, if there's anything that's wrong with the network connection, or even the backend services, if we're running against some backend that's not the production backend, but something that's just been deployed for testing purposes, it may not be reliable itself. We want to kind of silo ourselves off from depending on those services. And one more problem is we want to integrate all of this into our when we push our code, we want all of these tests to run automatically. And we never want the case where this test fails for no reason that's related to our change and stops us from pushing our change. We want them to be 100% reliable. And so I'd been looking into this a little bit, but one day my boss comes up to me and says, you've looked into this, you have some ideas, and I had a little bit of a crazy idea. And he says, you know what's going on, maybe. So stop whatever else you were doing and fix these tests. Spend, let's say, Thursday and Friday doing it. This is what I worked on for the next 2-3 weeks. So there's this idea of fixtures. So if you're not familiar with that, what we're going to do is make an HTTP request and actually access some data. But then we're going to take that data and write it to a file. What that file is, I'll get to later, but we'll write it to some file. That's called recording. And then we'll play it back by accessing that file directly instead of going to the actual live service. As you can imagine, this would be a lot faster. Hopefully your hard drive is not as slow as a network. And so this is what we wanted to do. And we had some ideas. And there are some modules that existed at the time. But they had some, they were not applicable to our case. So take, for instance, a test that we might have written. We'll make a request, but then we'll wrap it in some kind of VCR.record or whatever API it exposes. But this is not what we want, because this will record the HTTP request going from the integration test out to our Node.js server. That's not what we want to record. That we want to be live. So that doesn't work. Another thing we can do is try to take our Node.js server and put it through some kind of proxy, integrate some kind of proxy, and have it go to some other service instead of going to the backends. And that other service might do the recording and playing back of the fixtures. We spent a lot of time on that approach. Maybe it could have worked out, but there were some issues. And one thing I did not want to do is change all of the configs that we had that told us where the backend services were to point to some other server just for testing. So we gave up that approach. And I wanted something that was drop-in. So I decided I would create a module. And in Node.js, this is just how you import a module. And we want to put this in the server code. And I wanted that to be it. And the idea that I had may sound a little crazy, but it worked, was look at an environment variable. And if that's set to record, then just take the way we make HTTP requests, http.request, and store it and override it with some other function of our choosing. What this function will do is use the original implementation to make a HTTP call, but will also write to a file. And if the environment variable is set to playback, we'll do the same thing, but with different functionality. We'll read from the file. And if the environment variable is not set up at all, then it won't do anything. So this is what we want to do. And I want to talk about how we decide what file name we want to use. I should note the fact that we're overriding http.request is very nice, because even when we use a wrapper, like the request module, that makes the functionality easier, it still works, because ultimately it still goes through the same core API provided by the Node.js platform. OK, so the file name that we're going to construct for a fixture works like this. There's the HTTP method, the URL, and the request body. And the implementation details, we take them, we put them into an array, and then stringify, MD5, hash it. That's not too important. One thing that was interesting to me was why did I put them in an array instead of, let's say, an object? It's because if you put them into something like an object, then when you stringify, the order of the keys is undefined, and that can cause problems. It didn't in practice, but it's not something we want to rely on. So that was just something interesting that I realized later on. OK, so this should work, but it never does. And the reason is sometimes we have this type of request where the URL contains some parameter, like this request ID. What is this request ID? It's something we generate every time we're serving a request from the client, and we'll send it to every single backend service that we're going to access in order to serve that request, so that we put it into, it ends up in our logs, and it ends up on their logs, and we can correlate that this request spawned off these subsequent requests to the backend services. And so every time you run the integration test, this parameter will change. So how do we solve this problem of resolving to the same fixture file name without littering our server code with some logic? Let's say in test mode, we don't generate a request ID or something like that. We don't want to do that. And the way I decided to do this is to provide some kind of functionality where you could just say, for this type of URL, it's just a regex, apply this function that takes the URL, in this case, removes the request ID, and returns that. One key thing to note is that when you run it, when the URL filter is run, it doesn't affect the actual request that's made to the other service. It's purely for the sake of determining what file name is going to be used. I want to point out that this is something that was a guiding philosophy to me when I wrote this module. I knew from the get-go that I was going to open source it, and I realized this is a type of problem that other people might face as well. So I don't want to put in anything that's very specific to us. This is a very generic way of solving this problem. And the nice thing is that you can put this type of filter somewhere where you import the Sepia module, and that's it. It'll be contained in that spot. Also, there is a body filter that does the same thing with the request body. So once I had this in place, it was playing whack-a-mole, because the tests might fail once when I tried to play them back, and I have to go dig around and find out why they failed. And I find out, oh, there was some dynamic parameter like this, maybe a timestamp, maybe something else. And I have to add in a filter. And then that might allow the test to continue further and find another problem. Interestingly, there was one call that we were making that had this kind of dynamic data that was not actually used in the response to the client. It was a fire and forget. And I didn't catch that for a long time because the test still passed. Anyway, after doing all this, I went through and figured out the list of services that we needed to add these filters for. Finally, was able to get the tests recorded, play them back. The next image that I'm going to show means a lot to me. It has a lot of emotional impact because I timed how long it took to record it, and I timed how long it took to play it back. Can I read that? It's 1 minute, 21 seconds top. It's 2 seconds on the bottom. So this was a big improvement. And so now imagine this. Let's say you are pushing some code, and this needs to run in playback mode. Then it'll take 2 extra seconds. But imagine just waiting around for a minute and a half, not even knowing that the test will pass every time you go to push. Yeah, that doesn't cut it. So this was my big achievement. And when I got this going, I recorded all the fixtures. And what I did was put all the fixtures into our repository, because just like the test, they reflect the state of our code base. That is, with this code, these are the calls that are made, and these are the types of responses we're expecting to get back. Okay. At the same time that I was doing this, there was another redesign happening. And part of it was we were making some changes to the authentication. And the big problem there was that the authentication changes were supposed to be completely transparent to the user. And the only way they would differ is you would use one cookie versus another cookie. And so our integration test, what we did was we ran them twice. Once with the user who would get the first cookie, and then again with the user that would get the second cookie, and everything else would be the same. At least that's what we wanted. But the problem here is that we want to make sure that the cookies, both cookies are propagated correctly to the backend services. And we can't do that if all the requests, regardless of the cookie, end up resolving to the same file name. And that'll happen because it's still the same URL, same request body, same HTTP method. So again, I don't want to put in anything that's, we don't want to pollute our server code to support this in some kind of test mode. And I know this is a problem that maybe some other person will also face. It could be any set of cookies, authentication or not. So how do you solve this? Well, we don't care about the actual value. We just care about the presence of the cookies. So what we'll do is we'll take the cookie names, and just the names, we'll put them in an array and use that as part of figuring out what the file name is. But then there's a whole bunch of cookies that may or may not matter. And so there's this concept of a cookie whitelist. And again, you're just telling Sepia, hey, I care about these cookies. Take their names, use them when resolving the file name. The same thing applies to the header. So you have one header, or you don't have that header, it will affect what the file name that gets resolved. All right. So now you are in this situation where we use all of this information to figure out what file name it is. Okay. So everything's good. Both those sets of integration tests run perfectly. And in fact, if you think about it, we're running them twice. So that 1.5 minutes would become almost 3 minutes. So this is a pretty big win. So now we're integrating another backend service. And this one is for translation, to let the translation be provided by some other service so it's not part of our code. And so this actually has user impact. This is going to make the user experience better, and we need to get it in. But the problem is when we're trying to integrate this service, we find that somehow the calls that are made to that service are not the same every time. And that's been resolved now, but at the time, we need to benefit the user and get the system in. So how can we do that? Well, what we ended up doing, and this is another guiding principle of Sepia, is that it's all about being practical. Where you would configure the URL and body filters and so on, you can also say that something should always go to a live server. So it doesn't matter if you're in record mode or playback mode. You're going to go to a live server for that, any matching URL. So this is something that we had to do out of necessity, and we fixed it since, and it's faster now. But the option is there if it's necessary. Another consideration is something called a cassette. So a lot of these other VCR modules, they have this concept of a cassette, which basically isolates a set of fixtures into its own directory. You would typically do this at the test levels or the test suite. So you might say for one test, any fixture that's created while running this test goes into its own directory. And that's helpful because then you can look at one test and you can look at the calls that were made, and it's very isolated and easy to see. But the problem is the Node.js service doesn't even know what test is being run. It's just serving requests from the integration test client. So what can we do? Well, I had one idea. This is one where we had to make some trade-offs. But I decided that what I would do is when you import Sepia, then it would start up a little server of its own on a different port. And this server would be running the same process as the Node.js server and could affect global state. And in particular, whatever was running the test would make a call at the beginning of the test to change the test name or say that a test is beginning, and at the end to say that that test had ended. And the embedded server would change some state And using that state, when it was intercepting HTTP requests, would place fixtures in its own directory. So that worked. And all we had to do was add some before and after filters in our tests to actually make these extra calls. And it worked pretty beautifully. And on top of that, we also said that certain services, again, matching some regex, would have global fixtures. So there's sometimes some calls that we make for every single request, no matter what. And in this case, we would want them to not be replicated for every single test in each and every directory. And so we'd call them global, and they would end up in the same, in the top level directory. So this worked, but it has one problem. You have to set some state, and that means you can't run tests in parallel. So if you try to run 2 tests in parallel, what's the test name? So, and why would we want to run tests in parallel? It's of course faster, but it's already 2 seconds or something like that. The reason is because Sepia was used for another purpose that I had not even thought of when I created it, for performance testing. So obviously, whatever time delay that the backend services introduce contributes to how long it takes to serve a request, but at the same time, we want to make sure we're not doing too much CPU processing. Node.js is not the right tool for that. We want to make sure we don't have other inefficiencies. So we want to isolate any of the actual live HTTP calls and take a look at what our service is doing. And for that, we're going to simulate some traffic by running all the tests in parallel. So I think it's a cool idea, but we can't do it right now if we want to have isolated fixtures. So this is one case where we needed to concede to practicality and say, okay, we're going to pass in a header from the integration test. Our server code will have to be polluted, and we'll have to propagate that header. Sepia will pick up that header and use that to determine what the name of the test is so that we can isolate the fixtures. But it does pollute our server code. And that's a trade-off that we made. Right? So in going through this process, that's something that came up where we had an existing system. It's not like we could just change everything willy-nilly. We couldn't redo it. And maybe if we redid it, it would have been a different story. But as it is, we had to concede to certain practical concerns. Okay. So there are some other features. I won't go through all of it because it's on GitHub. It's the README covers all of the different features. But briefly, there is the verbose mode, so you can see what calls are being made and what fixtures they're resolving to. One feature that I really like that was implemented by one of my colleagues, it was when a fixture is not found. I mean, that's an error, and it should be presented as such. But what she did was, at that point, she would look through the fixtures, all of the fixtures, and try to find one that is close to the call that was actually being made. Not so that we can use that fixture and hide the error, but so we can report it. And one of the things that came out of this was we stored a lot of the metadata for the fixture. So you can imagine you just have the file name that some call resolved to, and you have inside that file you just have the response from the server backend service. But we also store some metadata about what HTTP request actually caused that fixture to be created. We have the option to turn off using the header and cookie names. Surely not everybody will need that. And then there's my favorite feature of all, whatever makes sense to you. Because I built this knowing that it can't be just us having these issues. And so that's why I wanted to make it generic and usable by other people. But all of this has been guided by the problems we've faced. And we think other people have this problem, but also there could be other considerations we haven't even thought of. So all of this code is available on GitHub. You can also install it through NPM, the Node package manager. And it's just drop in. So hopefully it'll just work for you. Are there any questions? Yes. Right. Yeah. Sure. It's a drop-in module that intercepts HTTP requests in order to allow creating and playing back of fixtures, so you can isolate yourself from live services. Yeah. Are there any other questions? Yes, over there. How many tests do we end up with? Oh yeah, it was 160 something, around that. Yeah, it was about 160 tests. We've since grown to more than double that. Plus, we're running the tests twice. One for the old authentication scheme and one for the new one. So it does take a while. And on top of that, we've had to make some changes due to the authentication changes where we have to integrate with some other services in front of us. So all in all, this whole process can be pretty lengthy if you don't isolate yourself from live services. Yeah. Are there any other questions? Yes?
What exactly you are testing when you are actually isolating from live services?
That's a good question. What are we testing when we've isolated ourselves from live services? So there's a contract that we have that when the client asks for some piece of data, then we will serve that data. And our code inherently makes certain assumptions about what the backend services will return as their response. So now there's this part of gluing those two things together. So given some piece of data that comes from a backend service, this is what the response should be. And these are the calls that should be made in order to create the response for the client. So we're testing all that business logic, the aggregation, the reformatting, things like that. Exactly. We're testing our server and just that part. And there is a fair concern there about what if something happens to the backend service that we want to catch. But we have to realize that this doesn't mean that we're not going to be running these. We can't run these tests in live mode. We still can. It's just that this is a sanity check to make sure that when we push our code, that at least our code is not the one that's broken. We have tried using performance testing as part of the push process. I'm not sure what the status of that is right now, but it is something that we can add in if we can gather the right pieces of data from it. Yeah. Yes, there's. Sure. So the question is there a facility for, I guess, in the server itself for handling errors from the backend services? Mm-hmm. Yeah. Okay, so how do we trigger basically an error from the backend so that we can test that? Well, first of all, there are unit tests that cover a lot of those code paths. Now, if externally we're able to tailor a request from the client in such a way that it will cause an error condition in the backend. So for example, maybe we request some entity with an ID that's missing, and what the Node.js server will do is pass on that ID to a backend. That's one way of triggering an error condition. So we can do that, and it'll be its own request, and therefore will be captured in its fixtures. Yeah. So if there's no way to trigger it from externally, then that's not a candidate for something that we can test in this set of tests, basically. There's a question down here. Yes?
So you said that this was server specific. So did you say that if anything changed in your server configuration, hardware, maybe even the type of server, would you have to be rewriting these tests?
Okay, so would we have to rewrite these tests if things external to our server, such as where they're deployed or how they're configured, changes? The way the tests themselves are written, it's very functional. We're saying, okay, the client would make this request, and this is what we expect. So typically, no, we wouldn't have to rewrite the test. If it means that something has changed where maybe we go to a different service to get that data, or something else has changed like that, we will have to re-record the fixtures. But it is helpful that we isolate the fixtures so we can rewrite it, or we can re-record them for that test only. Are there any other questions? Yes. Mm-hmm. Right. So when would we re-record those fixtures? How frequently? Basically, any time a call changes to the backend service. So when would this happen? Well, when we have been doing some internal migrations where we, instead of accessing one API, we're accessing a different API. And so then when we do that migration, we will definitely have to re-record. If we add another parameter to one of the backend services, we'll have to re-record. But usually these are isolated to certain components, right? So some test will test some code path where the calls have now changed, and we'll have to re-record those. I mean, the unit tests themselves have to be updated as well for that case. So probably at the same frequency as we would be changing our unit tests. Yeah. Yes. Does this module provide simulated data? So it's not simulated data in the sense that it's not something that's created. It is the same data that you would get back from the backend. But yeah, when we are playing it back, it is pretending to be a live HTTP call just from a file instead. I think we're out of time. So if anybody has any other questions, I'm happy to talk towards. Thank you.